Good morning. Today we are talking about direct variation. What you have to realize, first of all, is direct variation is the same thing as like a direct proportion, just like in our video. First thing I need you to do is pause this video, and I need you to print the application page because it's not part of your packet that is in your notes for today. So under where it says notes, direct variation, the second page of that says application page. We'll do 1 or 2 word problems from that. If you don't print it, just make sure you have a piece of paper so you can write down what we're talking about when we're doing it. Because I'll make it kind of I'll write it down kind of sketchy as well. So you can do that. So, you should have just watched the opener on the direct variation with Schmoop. He's a little confusing, but it's fun. So, what is direct variation? Lots of things he talked about in there, but a few things that we're going to talk about and we're going to expand upon today. Direct variation is a specific relationship in which there is a constant ratio. A constant ratio. The constant ratio is y over x. That is the constant ratio between the ordered pairs. When you're talking about a constant ratio, what else have we done that has been a constant ratio on a graph? Exactly. Slope is a constant ratio. It is the same idea as slope. It is the same idea as slope. And in fact, in our equation, it is exactly the slope in a graph. Exactly a slope in a graph. So that's why it's y over x. Not as complicated as our slope formula, because you're going to be finding a constant, which we call k. Our constant in our formula is now going to be k instead of m. That's a little weird, okay? Because our direct variation formula says y equals kx. Why is it not y equals mx when we know slope and this constant I said are the same thing? That is because this k can be a decimal where slope can never be a decimal. So when you're talking about direct variation, the constant of variation could be a decimal like 1.5. Where when you're talking about slope, it is always the relationship of change of y over change of x, so therefore it always has to be a ratio. Kind of the difference there. So with that as well, when we're trying to find this constant of variation, the reason we get y divided by x is because right here, if I'm solving for k, because y equals kx, then I can bring x to the other side, so my k equals y divided by x. So that's why our constant is just those two divided by each other. Now, with this, because I have told you it's like slope, it's the same thing as having y equals mx plus b, right? It's going to graph as a line because it's constant. It's going to be a line when we graph it. But the b equals 0. So that means my graph goes through the origin. That's a big deal. On your test, oops, sorry, you can't see it there. Graph through the origin. On your test, there's going to be 4 graphs, and it's going to say which one of these is direct variation. The graph is going to go through the origin. And all of this we're going to practice on in a little bit. I'm just giving you kind of the overview. But the graph always goes through the origin. Always, always, always. Sorry, my I and my N go together there. Always, always, always. Because in my direct variation, it's the same thing as this, but there's no b because it's plus 0. My slope, again, and my constant are the same idea, except this always has to be a fraction. This can be a decimal or a fraction. So that's kind of our overview of direct variation, okay? So now let's start trying to solve some of these problems. So the first thing we're going to do in our notes today is we are going to have to find k, the constant of variation. So if it ever asks you in the question, what is the constant of variation, they're asking you to find the k. What's important about the k is the word constant. Constant means it's always the same. That means if I'm looking at these ordered pairs right here, and I take my y and divide by my x, because remember, y equals kx, but if I'm just given here, if this is my x, this is my y. So if I plug it in, I can find k. So we said up there we could divide both sides just by x, so my k equals y divided by x. That should give me my constant. So here, if I just take my constant equals my 4 divided by 1, my constant is 4. But it has to be the same for all of them because it means constant for it to work. So let's just check them all out real quick. So 8 divided by 2, that's 4, that's good. Y equals 12 divided by 3, that's 4, that's good. Y equals 16 divided by 4, that's 4, that's good. So all I did was take all of these and divide y by x, that's it. So my constant then is 4. So my k equals 4 because it's constant in all of them. Then the equation to represent the relationship is just y equals 4x. It's just replacing the k in the formula or the equation and now making it y equals kx. That's it. Let's look at number 2. So to find my constant, remember we have to divide each of this, y by x. So 3 divided by negative 6 is negative 1/2. 2 divided by negative 4 is negative 1/2. This is the origin. He does not count because it has to go through the origin. 1 divided by 2 is negative 1/2. That means that, and again, just remember, to find that, I divided my y by my x. That's all I did up there. So my k, that's my k, my k equals negative 1/2. It's my constant is negative 1/2. So my equation is negative 1/2 x. Okay, let's look at number 3. All right, again, I'm going to just divide. Remember, my k equals my y divided by x. So y divided by x. So negative 8 divided by negative 12 is what? 2/3. Negative 4 divided by negative 6 reduces to 2/3. That's the origin. That's okay. Remember, the origin's always there. And then the last one here is 2 divided by 3, which is then 2/3. So they all come up to the same constant, so my constant is 2/3. So my equation is y equals 2/3 x. All right, let's look at our last one. You do it, and I will do it as well and see if we come up to the same answer. Check your work when you are done. Excellent, excellent work. Excellent job. So when you're given a chart into your work and it says you to find the constant or a set of ordered pairs, all you have to do to find our constant is divide the y by the x. But the catch is, I can't just look at this chart and do the first one and say, bam, it's true, because it might not work for all of them. So you do have to quickly check all of them. Just quickly check all of them because it might throw one of them off because you might be given a chart and it says, is this direct variation? Well, one of them in the chart might not work and then the answer is no, but you just tried the first one and you said, oh yeah, it works. So please be careful with that. Please be careful with that. The second part of the work we are doing today is going to say, okay, now that we've played around with this equation and tried to find the constant, let's look here and say, hey, is this equation direct variation? And if it is direct variation, hey, what is my constant? Well, here, if we're trying to identify the equation, remember the equation is y equals kx. That means when I solve for y, I have some number times x. This number here is always my constant of variation. So That's the second thing it says. So looking here at number 5, it's already in the form y equals kx. This is the number in front of the x. Remember, constant of variation is the same thing as my slope, same position. But remember, it has to be in that slope-intercept form. The same idea has to be in the direct variation form. Okay? So my constant equals 3. So yes, it is, and my k equals 3. All right, on number 6, you write that one out. Check your work. Check your work. Oops, sorry, that's k equals 4. Forgot my k. Now, number 7 is different. Is there an x in number 7? No, remember, direct variation is going to have a y and an x. Right here, there's no x. If there's no x, it can't be direct variation. Because remember, my constant is that y over the x. Or the formula just says y equals kx. So if we're missing the x, then we can't have y equals kx. Remember, direct variation is going to be a diagonal through the origin. It's not a vertical or horizontal line. Now, number 8. Number 8 is very similar, but remember, we have to solve for y, just like if we did slope-intercept form. So I solved my equation for y. Here is my constant. So yes, it is direct variation. Remember, it has to have the number in front of the x. You're multiplying that number by x. And I don't have anything added or subtracted. So as soon as I get something added or subtracted, the answer is no. So right here, well, can that be direct variation? No, you're right. Because this is where it's going to, when I've graphed this, if you remember from last unit, where I graphed this is -4. I cannot be adding or subtracting anything else because it's y equals kx. Not adding or subtracting anything. Remember, that's plus 0. So no way, Jose, can this be direct variation. All right, number 10. Can it be direct variation? Well, it's written y equals kx. So that's the first thing. So what would be my constant then? So it is in the right form because nothing's being added, but what is my k? Exactly, it's -1, because remember a negative x is the same thing as -1x. Excellent. Number 11, we need to solve for y. Remember here, when I have x divided by y, it's the same thing as 1/2 x. So yes, it's in direct variation, and then my k is the 1/2. So remember, it is the same thing. So on number 12, can it be direct variation? Well, no. Because why? When I start moving this mess around, when I get rid of my 4x, remember I got to put it like in basically slope-intercept form. Automatically right here, I'm going to have this +6 when I bring it over. No. No, 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 no. No way, Jose. Remember, it's +0. I can't have that. And I could totally finish solving this to be -2x + 3, but still, I'm going to be adding that +3. That means it is not direct variation. Direct variation always goes through my origin, which means my b is always going to be +0. So, looking at 13, will that work? Well, let's solve for y. All right, so +0 goes away, so yeah, it's going to go through the origin, so yes, it's direct variation, and then my k equals -5. Same position as my slope. The k is the constant of variation, where my slope is a constant ratio. Same idea. Same idea. All right, so now let's look at a graph. This should be easy because I've already told you a million times, the graph has to go through the what? I can look at these and not even do any work. The graph has to go through the origin. So right away, is this direct variation? Yes. Heck yeah. But then it also wants me to identify the constant of variation. Remember, the constant of variation is my k, which is the same thing as my m. So, my constant is the same thing as my slope, which is the same thing as my change of y over my change of x. So my constant is going to be 1, 2, 3 over 2. And I want to write the equation for the graph. Y equals 3/2 x. That's it. Easy. Number 15. No way Jose doesn't go through the origin, cannot be direct variation. Number 16. Yes, 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 because it goes through the origin, my graph. So then my constant is my slope, which equals what? I come up 1. I go over -4. So my constant equals -1/4. I just made my negative into the numerator. And then my equation equals y equals -1/4 x. Number 17. Yes, it goes through the origin. So k equals, sorry, the dogs are crazy. My slope, which is going to be 3 over 3. So my k equals 1. So y equals 1x or y equals x as my equation. Sorry, my phone went off. It was my son. That's okay. That's okay. That's okay. That's okay. So, number 18. Now we're going to find the missing value. So here, graph, just like slope. Don't make it hard. Has to go through the origin. Don't make it hard. Now, this is a little bit different. When we're trying to find with direct variation, what I like about direct variation is it makes a really nice equation. I mean, a proportion. If you remember proportions, we've done some things with proportions as well. It's all proportional, which means with this, if I take my x over my y, I can then multiply it out. So if I take my x over my y, it's just going to equal my x over my y. That's the same thing because it's proportionally related. It can do that. Now, that looks weird because we just said everything's y over x. Same thing. Y over x equals y over x. For it to work, it's basically their constants have to be the same. So this is just my constant value. If you wrote it x over y, same deal. But right now, the k equals the k, which means that the k to the first ordered pair equals the k to the second ordered pair because they directly have to be constant. Okay? So with that, this is my x, that's my y, this is my x, that's my y. So if I want to find the missing value y, remember my constant equals my constant. My constant was y over x and it's got to equal y over x. It's just a proportion. So now -4 over 2 equals y over -6. This is my first ordered pair's constant. This is my second ordered pair's constant. So now all I have to do is cross multiply and divide. And we won't do number 20 because I ran too far with that. Remember when you cross multiply, -4 times -6 equals 2 times y. So 24 equals 2y. So y equals 12. And again, we won't do number 20 just because I ran too far into that problem. So on number 19, let's set it up. Our k equals our k. So here, y over x equals y over x. Cross multiply. Divide by 16. My x equals 6. Perfect. Try number 21 on your own. Check your work when you are done. Check your work when you are done. Now, 22 is no different. Again, it's y over x for the first one, y over x for the second one. This if goes together. This find goes together. So it's still my constant equaling my constant. It's still my y over x equals my y over my x. So here it's negative 18 over 3, 30 over x. Now again, cross multiply and divide. Straightforward. Perfect. All right, I want you to do, I will do 23 together and then you'll do the last two on your own. First proportion, second side of the proportion. Check your work when you are done. (24) First side of the proportion, second side of the proportion. Set it up. Cross multiply. Perfect. Perfect. And let's just finish the last one on the page. Pause if you need to. And check your work when you are done. Now, with this direct variation, couple things. One, remember that you're finding a constant of variation. You're finding it between that separate ordered little pair. So it's like slope, but it's not exactly like slope. Okay? Because slope, you'd find the difference of two ordered pairs. This is just the one. It's always the y over the x equaling the other y over the x. So in the formula y equals kx, you can just use one ordered pair to find a constant. If you're given a chart, go through the whole chart to make sure everyone has the same constant when you divide it. Now I want to show you a few application problems. This is what I had asked you to print at the beginning. If you did not print it, then that's okay. Just kind of take notes on your own paper. Pause the video if you need to do that. Now it says applications of direct and inverse variation. The next class will talk about inverse variation and I will be back for that. So we'll review direct again. So with that as well, when we're talking about this direct variation, we're talking about here, you're talking about a direct proportion. So they're the same proportion problems you have done forever, which is why direct variation's so much nicer, because a lot of it is user-friendly stuff. But here, when you're talking about direct variation, and they were talking about it varying directly, that means if one variable goes up, the other variable goes up. That's why your graph looks like this, because it just keeps rising and keeps rising. By the same token, if one goes down and one, I think they both just go up. Actually, nobody goes down, sorry. So, with that, it's just basically your proportion problems you've had before. So it says, and I'll write out the important stuff in case you didn't print the page. It says the sales at a basketball game vary directly. That's the big deal you're looking at. Varies directly with the number of people attending. That's why I know it's direct variation. If the sales for a game are 12,000 when 800 people attend, determine if the sales are for a game determine how many people attend. Wait a minute, how many people attend if the sales for the game are 15,000? So here we're talking about directly. It says the sales vary directly with the number of people attending. So sales vary directly with the number of people's attending. So with that, and what they were talking about in the video was that would be the K. The K would be times the number of people attending. Or if you think about it, when you go ahead and solved for K, it's just the sales to the attending, which is the same thing you did back when you did proportions last year's. You could say if the sales for the game were 12,000, that's my sales, to 800 people who attended, then my sales for 15,000 are how much? So it's a direct proportion. That's what a direct variation is. It's a direct proportion. So it's the same proportion you've done in the past because the sides are proportional. So, and if I was to write it as a direct variation problem, then the sales equals the constant times the attending, because sales vary directly with the attending. But that's why it makes it sales over attending, sales over attending. And then I would just cross multiply. I'd get my 12,000x equals this big number, 1, 2, 3, 4, 5. So x equals 1,000, which means 1,000 people attended and paid $15,000. Let's look at one more. And these you've done in 6th and 7th grade, depending on the math you're in. So here it says the ounces of medication. So my ounces of medication, my medication varies directly with the weight. So my meds vary directly, K times weight, which just means that I'm just basically comparing my meds to the weight of the patient. That's it. So 100, and it's direct, so it's got to be the same on both sides. So 120 pound adult, sorry, I wrote that in the wrong place. 120 pound adult would be my denominator, because we know in the denominator is where I have my weight. I put it in the wrong spot, so that would be wrong. Sorry. So my weight was 120 pounds, requires 3/4 of an ounce of medication. So here's where things get great. 3/4 of an ounce is 0.75 when we're looking at a decimal. Okay? So now, how many or how much for a 200 pound adult? And all I did was divide the 3 by the 4. So now, how much meds is my Y? So 120Y, sorry, equals 150 when I multiply it. And you can leave it as 1.25. And if it asks, it's 1.25 ounces, because that's what my medication's label is ounces. Where is it? Okay. 3/4 ounces. So it'd be ounces. So it'd be 1.25 ounces. It depends on what it's asking for in your answer. 1.25 ounces. Because the medication's in ounces. We'll look at one more, and then you'll start your quick check. It says the number of shares varies directly, amount of dividends. So my shares to my dividends. All right. So, because Y is my share, you could do, or because that's like Y equals K, and then that's my X. I mean, my K we don't know, but that's my X. So my X is my amount of dividends, my K is my Y. So, again, we're talking here, shares to dividends. He's my Y, he's my X. Same idea as Y over X to find my constant, because that's all you're really doing is you're finding the constant variation. So, or finding out what the constant variation is in there. So, 5 shares of stocks to $12 per year for the dividends. Then how many shares of stocks to my dividends? Cross multiply. Y is 10. So when I cross multiply, that's 10 shares. It's knowing that he comes first, he's the shares. He's the same thing as the Y. Alrighty. Good luck with your quick check. Remember, on your independent work, you can do it twice. Wednesday, we have math help. I'll be available Wednesday afternoon if you need me. Have a great day.